So as long as it operates for 6 hours in the day, I'm going to be able to keep my house nice and warm at 25 degrees Celsius without having to do anything else. How much does that cost? That's the next part of the question, right? Well, I know how much energy I need to put into this pump, because it needs to operate at 4.8 kilowatts during 6 hours. So that's easy. I just need to multiply the kilowatts by the number of hours, and I can get kilowatt hours, right? So part B is asking us, how much does this cost? And we know, okay, so it's 11. I'm going to put the dollars here. I'll just do here. $11 per kilowatt hour. And I have something that's operating at 4.8 kilowatts for 5.895 hours. So guess what happens if I multiply everything? Well, my kilowatts and my kilowatts go away, my hours and my hours go away, and I'm left with the unit of currency, right? Amount of cost, the cost of this. And this turns out to be 3.11 cents. Right, so $3.11 is what it cost me to run this pump for a full day to keep my house nice and warm. And then the best part, I guess, is the last part of the question, which says, okay, but what if I were to use, let me just get the wording right. What if I were to use resistance heating instead of my heat pump, right? So instead of having, my heat pump here, put my heat pump here, my heat pump here operating, right, and doing this, grabbing QL here and putting QH here. What if instead I had a heating element that would convert through the Joule effect the electricity into heat, right? First thing we need to know is just that, the conversion from electricity to heat is almost 100%. So any kind of heater you have at home that you plug into electricity is just resistance heating. It's going to be almost 100%. Reason being, electricity has much higher quality than heat. So it's super easy for us to convert electricity into heat. However, the other way around is not true, right? Because heat has lower quality than electricity, we can't have a 100% conversion or close to that. It's actually much, much less, like 30% or so. So the question now is, okay, what if I didn't have this heat pump that is able to do all the work that I'm requiring in 5.89, what was it? 5.8 hours. What if I didn't have that option? Well, in that case, then I would need to use all the electricity to convert. So if it's 100%, right, if my efficiency is, let's call it 100%, then the amount of energy that I require to put into my home is the 58,000 kilojoules per hour, right? We had from the beginning, right? And we've calculated that per day, and that was what did we find per day? This guy here, right? This amount of kilojoules per day. No, this is with the heat pump. This is the amount of energy per day that we needed, right? So we would need to put in this amount per day. And if I need to put that amount per day, and I am paying 11 cents per kilowatt hour, then what does it cost? Well, 11 cents times 1.32 times 10 to the 6 kilojoules per day times 24 hours. No, we don't have the 24 hours per day. So we're going to get we need kilowatts, not kilojoules. So I need to know how much power I'm going to need, and the power is going to be this guy. Okay, so there's one extra step for us to do, which is this COP here. Where is it? This COP here will be 1 to 1, right? So you need to give the same amount of energy that I need to take out. So if I need to remove this, I have, okay, this is already in rate. Okay, so I just need to use that rate. Sorry. This is already a rate, so I just need to convert this into, oh no, I can leave it in that way. Just 11 cents times 58,000. This is per kilowatt hour. 58,000 kilojoules per hour. And you multiply this by, I have 1 hour for every 36 seconds. So this gives me now kilowatts, and I need to multiply this by 1 day, which is 24 hours. Okay, that makes sense now. Okay. So if you want to do it in steps, what I'm doing here is I'm converting this into kilowatt. Okay, so I'm removing hours and hours, and I have kilojoules per second, which is kilowatts, the amount of kilowatts I need, and I need that over a whole day, so 24 hours. So then kilowatts and kilowatts, hours and hours, and I end up with a cost of 40.3 per day. Okay, so this is 40.3 per day in comparison to the $3.11 per day. The interesting thing here is, what is this difference? Well, it's exactly the 12, right? Exactly the COP that we found before. Exactly the 12 point, what was the COP we found? 12.95, right? 95. 12.95. So if we didn't have that, you know, for every dollar we get 12, obviously we need to pay 12 times more to be able to keep our house warm under the same conditions if we don't have the heat pump and we're instead using electricity directly. So this is, you know, a very interesting problem in my perspective. I think it shows you the importance of the topic and how to apply it, right, in a real case example. So as per usual, guys, feel free to leave any comments that you might have down below in the comment section. I hope this video helped you out. If it did, consider liking it, and we'll talk soon.